Okay, so this call is being recorded. So in the last class, we talked about operators in Python, and it was an extensive or more of intensive. We went both extensively and intensively into that topic, and we covered the different categories we have from arithmetic operators to membership operators, right? And I can say, based on the amount of information poured out during that class, that we did justice to that um, topic, right? So just for revision purposes, the first thing to note is when you want to understand operators in Python, right? You should know that there are different categories. We have the arithmetic ones, the ones that we use to perform mathematical operations, right? The plus, the minus, the multiplication, the division, the modulus, among others, even the exponential operators, right? And then we also have another category which is the comparison operators that returns booleans in terms of checking whether what is to the left is greater than what is to the right, or vice versa. We also have the greater than or equal to sign, which returns true if the value to the left is greater than the one to the right, or is equal to the one to the right. The opposite of that is less than or equal to, which returns true if the value to the left is less than or equal in magnitude to the one to the right, right? Then we have the not equal to, which is kind of negation, right? So it returns true if the one to the left is not the same value as the one to the right. Then we have this um, double equal to, right? Which you can refer to as what this one does is it checks the one to the left and the one to the right, right? And then if they are the same, right, it returns true. Otherwise, it returns false. Then we also have the assignment operator, which in mathematics is our equal to sign. We have the logical operators, the and, the or, and the not, right? And the condition for and to return true is that all values being evaluated must be true. It's used to evaluate certain expressions or logic, such that if everything is true, right, then and returns the final value of true. Otherwise, it returns false. Then or, on the other hand, returns true if at least one of the conditions being evaluated is true. Then not. The not operator is used to change the output from true to false or from false to true. Remember, we are operating in binary here, being that the result you have can either be true or false. So if you have a result that if you have performed certain logic and then it returned a value true for you, if you pass it to this not operator, right, it converts it to false. Then we have the identity operators, the is and the is not, which we may not likely use that often, right? So and then this one is used to check if the IDs of the different values being evaluated in memory are the same, right? Then we have the membership, the in and not in, which we would use mostly when we want to perform search, right? Then a combination of all these is actually what serves as the brain or the building blocks of your code, right? So knowing them is important. And then after that, we discussed about operator precedence and then compound expressions. And then in operator precedence, I hope someone can still hear me. Please confirm that you can hear me. Hello? Hello? Can anyone hear me?
Yes, we can hear.
All right.
Yes, we can.
All right. Thank you so much for that. So, we also talked about the operator precedence, which discusses how the rules that Python follows in a situation whereby we have a combination of different operators, right? how will it know which one to apply first and which one to apply last, right? And we talked about compound expressions, right? How we can combine all these things together and make it to make sense. So just very quickly, um, we can brush through some of these, right? In just about, okay, so we'll use the next 10 minutes to just brush through them, and then we'll move on to the last thing we worked on, right? Which was on operator precedence. We had some few things to iron out, right? So, and then I included them in today's class so that we can move from there to now talk about the main topic for today. So just for the sake of those who were not in this class and you who may not have gone through the video, right? So let's look at arithmetic operators. Just imagine that Python is a calculator, right? And you are using this calculator to perform certain calculations like addition, subtraction, multiplication, division, right? As you can see here, we have 7 plus 9 returns from me 16, right? So Python can perform such operations for you. And then we can also see 20 minus 8 gives me 12. 8 minus 20 gives me minus 12, just like a normal calculator will give to you. Then in multiplication, you use this asterisk, this one that looks like a star, to multiply against what we are already familiar with, which is x, right? In normal mathematics, we do 2 times 2 to give us 4, but in Python we use 2 asterisks 2, right? So that is the operator for multiplication. So that 20 times 8 gives us 16, right? Now division, you use this sign, this forward stroke for division. So that as you can see here, it works out just like every other program, every other normal calculator, right? 20 divided by 5 gives us 4. 5 divided by 20 gives us 0.25, and so on. Now when you combine these two, the asterisk sign that we use for multiplication, when you combine it, like 2 of it, it is also an operator, which is an exponential operator, right? Which is to raise the value to the left here to the power of the one to the right, right? So that means 2 to the power of 3. 2 double asterisk 3 gives me 2 to the power of 3, which is equivalent to 2 times 2 times 2, right? That gives me 8, because 2 times 2 gives me 4, then 4 times 2 gives me 8. So that is what this one represents. This is just to play around values. Then what this one that we normally call percentage sign does is that it returns for us what remains after a division operation has been performed or carried out, right? So as you can see here now, this expression simply means what would be the remainder when 5 is divided by 2. And of course, when 2 goes into 5, it goes into 5 2 times, then remains 1, remainder 1, right? So that means 5 modulus 2 gives us 1, which is what we can see here. Now the second one is when you use double division sign, right? What this one does for you is it tells you the value, if the value to the left divides the one to the right, how many times can it do that for you? This one returns for you the remainder, then this one returns for you the what do they call it in math? I've forgotten the actual name. But what this one does basically is that it returns for you the actual value that you obtain, the whole number value that you obtain when the one to the left divides the one to the right. Let's look at it more closely. Let's say 11 double divide 2. It returns for us 5, right? But we know that 11 going into 11 can take place 5 times, right? So that means 2 times 5 gives us 10, then remainder 1. But this operator is not interested in the remainder. It's interested in how many times 2 can go into 11, right? The whole number that remains. So then it means that let's do something. It means that 5, let's say 11 double divide by 2 should give us 5, right? Then 11, if I do 11 modulus 2, what would that give us? That would give us 1, because 1 is the remainder, right? So what remains after is this, but the other one is interested in what is obtained as the whole value, right? Maybe you are trying to, where you can use this is, for example, you are trying to convert minutes. I mean, let's say you are converting from minutes to seconds, and they give you something like 75 minutes, right? That means minutes equal to 75, right? So then to convert that to how many seconds you have, how many seconds you get from that means, let's say now minutes. To know how many seconds you get in a minute, you do this double division, right? 60, right? And that will give us what? That will give us 1 minute. Then what is now remaining after that 1 minute, right? Then you can use the second operator again, and you will also say minutes, then this one 60, right? That means this is 1 minute. This is sorry, I was supposed to say 75. This is seconds rather. Let's say seconds, right, is equal to 75. They give you 75 seconds and you are converting it to minutes. That means minutes is equal to seconds double divide 60, right? So in 75 seconds we would have how many minutes? 1 minute, right? So let's say print minute. That means we have 1 minute, right? Now you know that 75 seconds is more than just 1 minute, but how many minutes do you get from 75 seconds, right? Now what is left? We still have something left, so that means we can use the second operation to still get what is left, right? So we can still come again. Let's say remainder. This is just a random variable. I'm assigning it. Is equal to minutes. Then use the percentage operator, right? 60. So that means seconds to minutes, right? We now want to know, after converting it from seconds to minutes, what would we get left? That means we now have okay, let's print minute. Okay, let's print minute. Yes. Then I would format this more properly. Then let's say means yes. Then remainder, then seconds. So let's just look at what it gives us. No. Sorry, remainder, then remainder, yeah. Okay, let me fix something. Seconds. Sorry, this will be seconds, right? So that means when you convert 75 seconds to minutes, it gives us 1 minute 15 seconds, right? So can you now see how these two operators come together to help you convert? You can also apply this. Let's say you are converting a certain value from, maybe the distance covered by a vehicle was given in miles, and you were asked to convert to kilometer, right? You can use the constant of conversion from mile to kilometer to get it, to divide the value in miles, right? Then to multiply the value in miles and then extract what is remaining. You still get it back in seconds. I hope this is clear enough. Hello? Hello? Someone should just give me that sign that you are still with me.
Yes, I
Alright.
can hear you, but I
Alright.
joined
So,
late.
Peter, can we make you like the class rep for today? That means whenever I say hello, I should be expecting you to unmute and then so that we don't, maybe just to confirm that you can hear me.
Okay, that will be a problem as long as not muted.
All right, thank you very much. So now, that was just to demonstrate those two operators because they can appear strange to some persons. So I think this example just adds more clarity to that. So this is just to play around. Now, um, let's move on to other operators. We also covered assignment operators, comparison, logical, identity, and membership, and the rest, right? So for assignment, what assignment does is it's used to assign value to a variable, right? It just like somewhere in memory, right? It's like giving name to a particular value which is stored in memory. So the actual value being stored is the one to the right, and then the name we assign that memory location that holds that value is the one to the left, right? So whenever I mention, I invoke this length, right, it returns a value of 2 for me. Or whenever I invoke width, it returns a value of 4 for me, right? Now, comparison operators are used to compare two values or expressions in Python, and what they do is they look at the value to the left and the one to the right and return true depending on the type of operator we used, or false depending on the type of operator, and then what the two values are, right? Then we have the equal to, right? For example, 5 is equal to 5 should return true for us because 5 is equal to 5. Not equal to, on the other hand, returns true if the value to the left is not equal to the one to the right, and vice versa, or the other way around, or the one to the right. Yeah, that's the same logic. Then greater than says it returns true if the one to the right is greater than the one to the left. I'm sorry, if the one to the left is greater than the one to the right. Less than is the opposite, such that if the one to the left is less than the one to the right, it returns true. Otherwise, it returns false. Then we have greater than or equal to, which is like this one, marrying this one and this one together, right? That is marrying the first and the third together, so that it returns true when the one to the left is greater than the one to the right, or the one to the left is the same value as the one to the right. So that's what greater than or equal to does for us. Then less than or equal to does the opposite, right? So these are just to play around with examples. Now we created something like a simple application, that authentication app, that asks users for their password and compares that with what is already stored in the database, right? So if they match, then it grants you access or performs a particular action. So in this case now, this is the actual username, which is Shegun. Then the actual password is Sam360. Now you will now ask user to enter a value input. This function is to get an input from the user, right? That is for both username and password. So that means this user enters this input, and this input is stored to this variable called username. The same happens here, and what you see in between inside the parenthesis is just kind of a text that tells the user what to do, what gets displayed, right? So if I run this code now, if I run this cell, you will now see that I'm prompted to enter the password, right? That means when I enter the username and password, if the username I entered is the same as if I enter Shegun, right, and the password I entered is the same as Sam360, then I will be able to, it gets to print this line of code that says successfully logged in. Otherwise, it prints for me, you have supplied an invalid detail. So let's try that. Shegun, right? Then password should be Sam360. then it prints form is successfully logged in because the input I supply is the same as what was being stored in the database, right? Then we also have the greater than, less than, among others. So we will not be able to go deep into all this. Okay, I did not run this line. Why is that again? Alright, so then I think we have to just move down to those were the main things we covered in the operators, and I keep emphasizing that operators are very important, right? Because it's with this that you can start creating your logic, the logic for your code. Now the part that we need to brush up from the last class is the operator precedence, and what they do is the order in which the operators are being evaluated, or the expression is evaluated. That is, when you have two or more operators in Python, how does Python evaluate them, right? How will you know that it should it do multiplication first, or division, or addition, or subtraction? How exactly is it going to handle that? And then the framework we are using is PEMDAS or BODMAS. And then for during our basic maths, that's in college, of course, in secondary school, we must have in one way or the other come across BODMAS. But PEMDAS is the same as BODMAS, only that PEMDAS is the American flavor, or the American version, how the Americans pronounce it. But you find BODMAS among the British speaking world, right? You come to Nigeria and Ghana, Kenya and the rest, yeah, they work with BODMAS. And then that means they are the same thing basically. So what do they stand for? The P there stands for parenthesis, right? Which means in expressions, in mathematics and other expressions, right, you can use parenthesis to something like this to simplify, that is to separate, to group your sub expressions, right? We have the exponents, which is when you are raising to the power of whatever. We have multiplication and division. You can see that the two of them are on the same line. Then we have the addition and subtraction, two of them on the same line. So what does that mean? It means basically that parentheses have the highest precedence. And what that means is that in any expression, right, that involves parentheses and other operators, right, Python will evaluate those values within the parentheses first, simplify them first before it proceeds to the next line. After simplifying the parentheses, it moves on to the exponents, which is when you are seeing something like 2 to the power of 3, 3 to the power of 8, and so on. Then after doing that, it also comes to multiplication and division. Now here, multiplication and division have the same precedence. They are at the same level, meaning that it can choose to start with multiplication or division. Then addition and subtraction, the same applies. That means in hierarchy, multiplication and division are of higher hierarchy than addition and subtraction, right? But then there will be a problem somehow if we have an expression that involves multiplication and division at the same time. How will Python know which one to handle first? Then there's another rule, which is associativity, right? Meaning that when you have such case, right, depending on the type of expressions being evaluated, Python would either start from the left to evaluate. That means if we have multiplication to the left, division to the right, it would multiply first before coming to divide. The same can apply to addition and subtraction, right? Now, the term associativity is very important because it tells us when you are kind of at a blocker, maybe you encounter a blocker whereby two operators of the same precedence, right? How will you know which one to now use? So this note here is just to shed more light on that. That means that for any expression, the sub expressions inside the parentheses are evaluated first, then exponents followed by multiplication and division, which is evaluated from left to right, and then division, addition and subtraction that are evaluated from left to right. Now, left to right is used here because most of the expressions you find in mathematics or in Python would are left to right associative, right? But it is not always the case. Now let's look at this note. If, for example, we have parentheses, okay, yeah, I think this is what I already explained. But here, just saying that parentheses have the highest, followed by parentheses have the highest, multiplications and division have the same precedence, just like addition and subtraction. Then, when operators have the same precedence, then associativity determines the order of evaluation, which is what I've been trying to say all this while. Now, let's look at this expression, for example. We have this value called result. This expression called results or equation, whatever. Now we can see that from here to here, we have how many operators can we see here? The addition operator, multiplication, right? Then the addition, right? Then of course we have this parenthesis, which is not really an operator, but it's still used, right, to keep things organized. That means for me to evaluate this, for Python to evaluate this, using the PEMDAS framework, right, it means the parenthesis, what is inside this parenthesis will go first. So it would leave every other thing and come here first and do 4 plus 5. That gives us 9. Right? That gives us 9. So it then replaces everything here with that 9. So we now have 2 plus 3 times 9, right? So that means, let's say, the first level would now give us 2 plus 3 times 9. This is what this equation melts into, right? So I think it's broken down here so let me just follow it. So 4 plus 5 gives us 9. Then multiplication comes next, because in PEMDAS multiplication and division come before addition and subtraction, right? So when multiplication is affected, that means 3 would multiply this part. That means 3 multiplied by 9 gives us 27. So what we now have left is 2 plus 27, right? So then that would simply then will now the addition operator will now come in next, and then that finally breaks it down to 29 for us. I hope at this point you are still with me. You can still hear my voice.
Yes, we are with you.
All right, thank you. Now, we just evaluated this using the PEMDAS framework, right? And then following we've not really come to the case of left to right hand rule, right? So we just because we did not encounter a case of maybe we had two equal values that are of the same power, of the same precedence. Now let's look at another one whereby we have exponentiation and multiplication. In this case, can someone tell us what is going to be evaluated first when you have 2 times 3 exponential 2? Which one would come first?
The exponential.
Okay, that will give us 3 to the power of 2, right?
Yes.
That will be 9. Then 9 is replacing everything here. So we'll now have 2 times 9 to give us 18. That's why we obtain the result 18. Alright, so the same. This is just like a breakdown of the steps. Now let's look at associativity, right? Associativity is really what determines or what tells us whether we are going to use left to right hand rule or right to left hand rule, because both can work, can work. For example, if for example we have this expression, in this expression that we have here, right, we have 10 minus 5 minus 2, right? So how will you know which one to do first? Will you come and say 10 minus 5, then whatever result you get, you now come and say that value minus 2? Or will you now come the other way and say 5 minus 2? Whatever value you now get, you now come and say 10 minus that value. I bet you that if we try these two, right, they are going to give us different answers. For example, if we say 10 minus 5 first, that will give us 5. They will now have 5 minus
Sorry,
2.
I can't hear you. I don't know if others are having the same experience.
Okay, All right. Can you hear me, Peter?
Yes, I can hear
Hello?
you.
Okay.
I think his network failed.
All right. That means Eben, you'd have to try and maybe rejoin because I can see it's a network problem based on our confirmation now. So if I start with the one from the left here, right? 10 minus 5 gives me 5. Then that 5 replaces everything here. I'll now say 5 minus 2 to give me 3, right? Or someone else can come and say, if we don't have a standard framework like this PEMDAS and the rest. Oh, sorry, let me check my stream. Something has gone wrong. Alright, we're back. So if, for example, we don't have any a framework such as a PEMDAS, right? It means we will be confused because the second person can come and start from the right and now say, okay, it's 5 minus 2 first. That gives me 3. Then I'll now come and say 10 minus that 3. That gives me 7. You can now say that the first operation results in 3, while the second operation results in 7. So how do we do that? Now let's use the associative rule. The rule states that, okay, for most operators in Python, they are left associative and then they are evaluated from left to right. For example, if it is division, addition, subtraction, and the rest, those basic arithmetic operators, right? They are left associative. But there are some cases that are not so. For example, exponential or exponentiation operator, so they are right associative, and then we cannot evaluate them using left to right. Instead, we use right to left. We still have an example that illustrates that. If I have this expression 3 double asterisk 3 double asterisk 3, right? How am I going to know where to start? If I start from the right here, right, I will say 3 to the power of 3 to the power of 3. If I start to the right from the right, I will still have 3 to the power of 3. Then whatever I get, 3 to the power of that thing, right? So left, just know that exponential operators or exponentiation operators are right associative. So in this case, I would start from the right. That means these two will be evaluated first. Then whatever is obtained, right, we will now say this one to the power of that which was obtained. So we will now have 3 to the power of 3, that gives us 27. Then we'll now come again and say 3 to the power of that 27, that gives us this value, which is a whole lot of money if you convert it to dollars. That's by the way. So this is just like a breakdown of that. So the first part is to start with 3 to the power of 3, that gives us 27. Then no, sorry, this is this illustration here is the incorrect one, right? The one I just demonstrated earlier is the correct one, whereby we start from the right and move towards the left. So 3 to the power of 3 gives us 27. Then 3 to the power of 27 gives us this value. But if we had started with from the left, right, we would have said,
Is it possible maybe you use a different numbers? Like,
okay, all right, I understand. So let me use another number. Let's say
Oh, sorry.
yes.
Can I say something?
Hello? Yes, you can.
Okay. So, yeah, we can try a different number, but I think even with this example, it still work because the reverse will just be 27 to the power of 3, while this is 3 to the
Yes,
power of 27.
yes, but let's just try another. I hope my background is not too noisy. Okay, I think the value is too much. So let me just reduce it to let me just reduce it to 2 to the power of 4. Let's see if this will work. Okay, this is a whole lot of number, right? So I think it has exceeded the limit that the Python can even support. So if I use another example here now, we have 2 2 double asterisk 3 double asterisk 4, right? So what you get here is that if you start from the left, you're going to say 2 to the power of 3 to the power of 4, right? So what that means is that we are going to end up with, let's say, this one. Okay, now we simplify this one now, right? That gives us 2 to the power of 3 gives us 8, right? They will now come and say that 8 to the power of 4. Let's see what that gives us. 8 to the power of 4 gives us 4096, right? But that is different from the value we have here. So in this case, what we are supposed to do rather is you go from the right first, right? And then you start with this one. Do this first. 3 to the power of 4. 3 to the power of 4 is about that is 27 times times 3. Okay, let's say 3 to the power of 4 gives us whatever value is 81, right? 81. Then having done that, we'll now come and say 2 to the power of 81, right? So if we now say 2 to the power of 81, we'll now have the same value as we have before, right? So I hope that simplifies, I hope that clarifies that, right? Hello? Hello, can you hear me?
Yes, you can.
Alright.
Yes.
Alright, thank you. So the next thing, so I think that clarifies the confusion we had in the last class, right? So with this clarity, we can now move on to the main topic of the day, which is data structures, right? Or does anyone still have a question? Anyone?
So, sorry,
Yeah.
to clarify what you said, right, the right to left associative only applies to the exponential, right?
I think explanation is just one of them that I can think of for now. But the first thing is maybe we just perform side because there could still be more. Let's just say um, right to left. Okay, right. Associative
Sorry,
operators.
Ken.
Yes, I can hear you.
Sorry, I just noticed something, so I just had to come in.
All
Is it
right.
your computer that is making this noise in the background?
What?
Your system? Is it your system that is making this noise, like this sound I'm hearing?
What's the sound? Okay.
I'm hearing it sound like your system, the fan, your system is shouting
Well,
because I'm seeing your tabs and it's looking clearly that you're overpowering your system. I don't think it doesn't damage. Happened to
okay.
me
Well,
last
well,
month. My
well,
system.
I think one of them could be that the generator is on,
Oh, okay, accept that. Because the noise I'm hearing, I got scared. I think,
and
what happened to
I'm
you?
not putting on any headset that can maybe serve as noise filter. Unfortunately.
No, it's okay. It's okay. I was just worried about you.
All
It's
right. No,
fine.
no, no. I think my laptop can is strong enough to carry the application.
Again, again, the is echoing. I don't know if it's for
Sorry,
it's echoing.
echoing.
Yes, like it's
I can actually
dragging.
hear you. So
Like
consider really checking your system. Sorry, your network.
My network. That means is my
I think
voice.
you also echo.
My voice is behind or what?
No, your voice is okay, Ken. I'm
Okay.
suspecting his network is a little bit poor. That's why it's echoing.
Okay. All right. So maybe if you're having such experience, maybe you can still rejoin and see if that solves it before. Yeah. So what I was saying is that um, you may not have the complete list until you search, right? But most of the operators, right, could. Maybe write us. Okay, right. Blah blah blah. Let me start with this question. Yeah, this is just like. Okay, I think we
Sorry,
have
can I ask
another
a
one. We have another
question?
one like. I think from what I can see, we have another one like. Hmm? This is incrementors also. When you want to increment or decrement, right? Well, I'm not sure we've gotten to so complex these things that will require us to come across maybe this kind of code or something like that. So for now, we can just take note of the exponentiation operator so that we don't. It's something you could research further. So let's proceed to the main topic of the day, unless anyone has another question.
Yeah, I have a question.
All right.
Okay, just for clarity, so whenever we talk about associativity, it has to do with operators of the same level of existence, right?
Associativity, right?
Yes, yes.
If it has to do with the operators with the same level
Like
of
in the
precedence.
question where just just subtraction use of or addition use of or subtraction use of an example. Just trying to write you.
Sorry,
So
but
is
I
that
can't
more
really hear you
like
very
it?
well. Can someone else maybe?
Okay, can you hear me now? Can you hear me now?
Yes, I can.
I'm just trying to verify that whenever we talk of sensitivity with respect to Python,
Yes. Hello. I think my network has gone. Hello. Hello. My network kicked me out. Sorry about that. I hope you can hear me now. Hello. Can anyone hear me?
Um,
Okay, you can hear me, right?
Deborah, sorry, is there a way to reach out to him so that he will know that he's up?
I'm
Let me
here
reach out
already.
to him. Just a moment.
Okay.
Hello.
We can't hear
Oh,
you.
oh, sorry. Network kicked me out, and I came back and did not remember to unmute myself. So I'm very sorry about that. Can you? Okay, let me share my screen again. Can you hear me now?
Yes, we can hear you.
Okay. All right. You can see my screen, right? Hello. Hello, Peter. Can you? Come on, my network is going bad. Can you hear me? Can you confirm that you can hear me? Hello.
Yes, we can hear you now.
Can you see my screen?
I don't know if you started sharing your screen.
Hello, hello.
I can hear you.
Can you see my screen?
Yes, you can see your screen now.
Okay, so please, you were asking a question. Someone was asking a question. Can you ask the question again,
Yes.
please?
Okay. Eh, Okay. Thank you. Can you hear me clearly?
Yes.
So I was trying to confirm that based on what you said so far, is it okay to say that whenever we talk of associativity with respect to Python, it always refers to when you are dealing with operators of the same level of precedence? Because you know, the example you gave so far were clear cases of where it was just a particular operator used in this question. For example, the one that has 10 minus 7 minus 3, full example of experimentation, where it was 3 to the power 5 to the power 4, something like that. Just for clarity.
Okay. I would say I still struggled to hear you, but let me explain based on what I heard. So, of course, in mathematics, associativity is one of those characteristics of certain mathematical operations, right? We have associativity. We have what are those? Is it commutation or something like that? There are a lot of some of those identities or operations in general mathematics that you come across. For instance, you can have something like maybe they will tell you that 2 plus, I may not be able to get the actual name now, but 2 plus 2 plus 2, or 2 plus 2, or let's say 2 plus 3 plus 4 is the same as 2 plus 3 plus 4, right? That is true, right? That means if you start from here, if you start from here, that means if you do this one first, then add it to this one, it will be the same thing as starting from the right, right? Doing these two first, then adding this one to it, right? So that is a, I guess that is a is that associativity? I may not be able to get it right now, right? They still have it for both addition and multiplication. Like if I have 2 times 3 times 4, let's say is equal to 2 times 3 times 4. Let's say I start with this one first, then, or in the same as starting with this one, right? So now that tells me true, right? So there are some of those rules in mathematics, right? And what Python does is it simply follows those rules. There are some operators that do not follow this rule. For example, exponentiation, which we just demonstrated, right? So in the case of exponentials, right? Let's try something out. In the case of exponentials, let's say 2 to the power of 3 to the power of 4. Is it the same as this? Let's say now I start with this one first. Is it the same as when I start from the other side? Now let's see what
No.
happens. It tells me no, right? So it means that exponentiation does not meet that particular requirement, right? Or it breaks the rule of I am not so sure if this is a associativity or commutation, one of these, right? Maybe I can verify that. Sorry, we are going to mathematical now. Let's say commutation in mathematics. right? Or commutative property, right? Properties of this thing. Let me give examples. Let me say, okay, like in this case now, 5 plus 3 is equal to 3 plus 5 is equal to 8. It doesn't matter whether you start from the left or the right. Then for multiplication, we have that 2 times 4 is the same as 4 times 3, 4 times 2, right? Commutation means that if you start from the left and do, that means doing the first one, bringing this one to the left and adding it to the right one will still give you the same as when you do it the other way around. Like you can see here now that 2 is to the left and then the operator is in between, then 4 is to the right. And that still gave us the same as when you have 4 to the left, then the operator, then 2 to the right. That is commutative of property of numbers, of real numbers, right? Real numbers. Now, if you still have other properties like associativity. In this case, the associative property. In that case, you have something not so different. Like in this case now, let's say examples. Sorry. The associativity here states that when you start with this now, you can see this expression 2 plus 3 plus 4 gives us the same as 2 plus 3 plus 4. That means doing this one first, 2 plus 3 first, then adding 4 to it is the same as when you do 4 plus 3 and add 2 to it. It gives us 9. We have it for addition, we have it for multiplication. When you multiply 3 and 4, it gives us 12. Multiply by 2 gives us 24. When you multiply 2 and 3 gives us 6. Multiply by 4 gives us 24. So these are properties of real numbers, right? And then the operators we're applying, that is real numbers and their operators, multiplication and addition. Now in the case of exponentiation, right, it breaks that, it doesn't have that property. You can see that we started from the left, multiply these two, got the exponents of this, and then brought it forward to this one, and it gave us a different thing from the one when we started, if we had started from the right. So that is what it is. So associativity is a property of numbers, right? But exponentiation breaks that, does not allow those numbers to maintain those properties. We still have many of them, identity and a lot of them, but we're not going into mathematics now. I hope that clarifies the question you asked.
Very well, very well.
Thank you very much. So now the main topic for today is data structures, and then we spent almost an hour on revision. That's interesting. So what are data structures? We've already had a class on data types, during which we discussed extensively on what data types are, why they matter, and the rest, right? Today we are looking at data structures. Data structures are like, should I say, different ways you can bundle a group of items of different data types together. You can just see them as a basket that contains a certain basket you can use to pack elements or data, for example, right? And then there are different kinds of things that this basket can hold. There are certain baskets that can only contain the same thing. For example, if you have a crate of egg, for example, it is expected that you don't use a crate of egg to carry water, because it does not support carrying water, right? Let's just see egg crate. If you have this crate of egg, right, then it is expected that whatever it is going to carry is going to be an egg, right? So if you put water in this thing, it will not work as expected, right? Now the same can apply when you are working with in Python or other programming languages. If you are already also joining our R class, then this has also been discussed, I think, in two classes. Now, data structures are ways of organizing and storing data so that they can be accessed and modified efficiently, and they are fundamental to designing efficient algorithms, and they are also critical part of computer science and software engineering. That's just for you to know. So why are they important? Because the first thing is to look at efficiency. So the the structure you use can greatly determine the efficiency of your code, right? In terms of the speed and every other thing, even memory management and even mathematics data manipulation, the kinds of operation you can perform on them, right, can be influenced by their data structure. So now in Python there are four traditional data structures, four fundamental ones, right? We have the lists, the tuples, the sets, and dictionaries. And then why I mentioned that they are traditional or fundamental is because when we start talking about discussing frameworks like pandas, like numpy and the rest of them, you are still going to see that these frameworks have their own kinds of data types, structures, different ways that they package. You can still package data in them. For example, in pandas we have pandas data frame, we have pandas series. In numpy we have numpy array, right, among others. Now this is like a summary table of each of these, just like a high level overview of what they are, and then we would have an intensive should I say a discussion of each of them. Now let's look at lists. Lists is a just like a collection of items which are ordered and mutable. Mutability means that you can change or modify the value after you have created it. Ordered means that you know their positions are marked in a way that each of the data that occupies a particular position is already, you can trace where a particular value is located or whatever. Then we have another one called tuple. Tuples are also ordered, but they are immutable. Mutability means that you can change the value, modify the value after creation. So they are still a collection of items, but they are not mutable even as they are ordered, right? Now the third one is set, and this one most of us should be familiar with what sets are. It's an ordered collection of unique items, right? In sets they are not ordered, and another thing about sets is that they cannot contain they must contain unique items, right? So the items that they contain must be the same, different, like unique, right? Then we have dictionaries. Dictionaries are also unordered collection, and then they use key value pairs. That is a key, each value it saves. It's just like a big list of libraries. Variables. In variable we see that the one to the left is the name of the address, name of the name we assign to the memory that contains the main value. So, but not exactly though. So let's look at their usages. This table helps us to look at them side by side, right? So when do you know you should create a list instead of a dictionary or a set or a tuple, right? If you are creating a simple list of maybe values that are iterable means that you can run a code, like it supports being able to go through each of the items one after the other. That is to iterate, right? So you can create a list for that, and then you need to maintain and then also you can use it when you need to maintain an ordered collection and perform things like append. You are expecting that the list is going to continue to expand, or you should be able to delete values from that list, from that collection, or assign or change the value from that to in that collection and the rest of them, right? And then another thing, let's look at tuples. Tuples are used for collections that should not change. If for example I am a geographer, or should I say a meteorologist, and I work with or even a geologist, whichever one, and I work with a lot of coordinates, maybe geometric values or coordinates, maybe the latitude, longitude of different points in space and all that, right? And I expect that these values for every latitude there is an accompanying longitudinal value. For example, I have something like a in let's say the latitude and the coordinates of Nigeria, for example. You would always find coordinates of Nigeria in this order: 9.082 blah blah blah. That is using this should be the in degrees or so, right? The north and south, the pair, right? They would always come in pairs, something like this. If, for example, I'm always expecting that I have these values in pairs, right? The coordinates of Nigeria can never be complete. I can never know the location of Nigeria if I don't have these two values together. Let's say what I have is just this one. What I have is just this one, for example. Then there is no way I can work with it, because this can also this is just like showing us the longitudinal component, right? So I would expect that these two values can always be the same, will always go together, right? I can choose tuple to pack two of them together, right? Another way we could have done it is, let me just generate list of let's say I can ask maybe to generate just a list of random coordinates. Let me just do random coordinates. So I now have longitude maybe minus 23.4.5 minus 56.7 or 0.9 minus 10 minus 10.8. Then I have another list that contains latitude, which is equal to 23.2 or 0.4 or okay, let's say 0.0, 13.5, 17.9. Now you can see that I'm trying to describe just three different points in space. This and this will always go together. This and then this one will always go together. Then finally this and this one will always go together. But then that means my list is already, I now have two lists that contains these two values, right? So what can I do? A better way to handle this very well is that I can just convert this into a tuple, right? That gives me something like this. Each of them has their own coordinates. That is a minus 23.5 comma 23.0. It's easier for me to see them side by side. Then another one containing minus 56.7.9, then 13.5. Then the last one containing minus 12.9 and then 7.9. Now this is like a tuple of tuples, right, in a sense, right? But you could see that each of these, it's easier for me to modify. If I want to make any change, right, I can easily modify them, and I can easily verify that these two values are the same, are pointing to the same value. And if, for example, it's easier for me to write a code that pulls the value for coordinates, that is for the longitude and latitude together, and performs a particular action, than for me to come here. Get the latitude first, then come and iterate through this list again to get the corresponding longitude. So you can now say that this one is going to definitely run faster, right? Because it already has the two values together. It doesn't need to run another line of code. I'll come and iterate over this one, then come to this one again. Those, and even me as a programmer, I can easily modify. Maybe I made a mistake here that this is supposed to be 7. It's actually supposed to be 9.7. I can easily see that here, looking at this one now, 7.9 instead of 9.7. 9.7, because when this list becomes so long, if this list extends to somewhere here, right, I will not be able to see it side by side the way I'm seeing it here. I think that kind of creates initial sense of like idea as to why this matters. Then you should use this that one of the usages is for collections that shouldn't change. Another thing about tuples is that these collections are not expected to change. The coordinate of a particular location will remain so throughout my operation. Like there's nothing like a increased that this value changed. But like there's nothing like maybe the coordinate changed over time. Like I'm expecting that this remains kind of constant, stable, right? So it means that if I'm checking something like the speed against direction, right? And then maybe I'm looking at something that will continue to increment sporadically, right? I can't modify this thing directly again after I've created it, right? So when the data should remain constant, example coordinates or fixed sets of elements, you can use tuple. Then the other one is set. Set is an ordered collection of unique items, and it's ideal for membership testing and removing duplicates, especially removing duplicates, right? Maybe I have a long list that contains thousands of students, and then it's possible that certain IDs repeated, right? I want to perform operation that identifies each student uniquely. I can just maybe pass that list to a set, and then it filters down everything to just unique values. So when you are storing unique items and performing union, intersection, or difference operations, the last one we look at, which is also very important, is dictionaries. They are unordered collection of key value pairs, and they are great for fast lookups and updates using keys. Okay, now you need them when you need a logical key value mapping similar to a database or record. These are just English. What they are saying is that for dictionary, right, you get each of the values you are storing, right, is you have a name that you can use to associate it with it, right? For example, this thing that I have now, if for example I want to create a list of let's say I have a list that contains students. Okay, let's say scores of a particular student that they maybe after a particular course, let's say 79, 98, 100, 37, 67, 85, 86, right? Let's say for each of these now, it might be difficult for me to know which course, which subject is this that this student made 79 in, which one is it that this student made 98, and so on and so forth. Now it's easier in that situation for me if I had created a dictionary that contains the key value pairs, so that for that particular student, let's say Mark, I want to create a dictionary that contains the score versus the value and the name, right? So I can now say English 79, math 98, geology, geology 37, agric 67, then finally economics. I have 86 here. Now tell me, between this one and then this one, which one is more memorable? The first and the second, which one is more memorable?
The second.
The second, right? But the use case actually depends, right? The use case actually depends. So it's not in every case that I would need to store a value as a list. It's not also in every case that I need to install values as dictionary, right? If you are from another programming background, like maybe JavaScript or so, right, you can Python dictionaries are just are called JSON in other like programming language like JavaScript and so on and so forth. Right? It's just JSON, right? Although with little nuances. So this one stores values as key value pairs. Now, if I was to have this thing as a tuple, right? Maybe I just want to put all these things side by side, different ways you can store them. Let's say as list. The second one is as tuple. If I was to store this as tuple, what I'll have is maybe English, just using English, comma 79. Maths, let me just copy this. Geology, $37. Sorry. Then agric,
67.
Now you also should take note of the syntax, right? There are those that you separate using colon. There are those you separate using a comma. Right. So I have this. So imagine that I want to write a code. I want to write a code that requires knowing the course, the particular course, and then the subject, right? I mean the particular course and the score. This is what, if I had it in tuple as a tuple, or I can even maybe convert it to, maybe it could be, I can choose to have this as a list of tuples. Maybe I call it mark. List of tuples. I know that this contains English, blah blah blah. I can still have it as a tuple, as a dictionary, as whatever, right? Now having this as a set, right, is going to be a bit tricky because set requires unique values, right? So set may not really be the most appropriate value, because imagine that maybe the person scored the same value, made the same score on two different subjects, right? Set is not going to consider that. Another thing about set is that it is unordered, right? Just like a dictionary, only that in dictionary, even though it is unordered, you can still use the unique, that is the key, to retrieve the value, right? In dictionary, if someone had scored the same had made the same score for two different courses, at least the name of their keys are different, are unique, right? So in dictionaries, what is unique is the keys, right? But the values can be different. So that's why they say key value pair, key here, then value here. So if I replace this with equal to, right, can you see that it looks very similar to just the normal variable, but this is not the right syntax. So you can just see this as a big list of variables and their names. That means and their values. That means the one to the left is the name of the variable, the one to the right is the name of that's the value being stored. But this is just like an analogy, right? Now we have looked at this like an overview, high level overview of the different structures we have. We now want to go into specifics like lists, and it's obvious we'll not be able to cover everything today. This is 37%, because this is already 8:49. That means we have about 30 plus 12, 40. Oh, that's interesting. Maybe we'll still have up to 42 minutes. As if my battery can take us up to that. So let's take the first one, list. At this point, does anyone have a question?
Yes.
Okay, can you ask?
Firstly, am I very audible? Last time you didn't hear me very clearly.
Well, you can start. Let's go on. Come on.
So you can either represent it when it comes to data structure, you can either represent it as this tuple set of dictionary. However, out of all the four, the one that is the most efficient can better suit that kind of data. Because from the last example you were giving, you could see that the data you were working with, you could express it as a dictionary or set or this or that. However, it was the dictionary form that gave the best representation of that data. So you guys good way to summarize the whole difference. Just better understand.
Hello, can did anyone hear him that can help me really? Because I don't think I heard him very clearly.
Okay, can you?
Yes, I can hear you. Hello? Hello? Can you all hear me? Oh, my network has kicked me out again. Hello? Hello, Gabriel, can you hear me? Okay.
Hello, we can hear. I can hear you.
Okay. So, that means who was speaking then? I guess it was Peter or Eben or someone else. Maybe if
I
anyone.
think he's having network.
Alright.
For him to reconnect.
Alright. But did you hear what he said? The person asked the question.
Not at all. Not at all. Network was breaking.
Okay. Alright. So maybe let's hope that he joins back and then fixes the issue. But we'll have to proceed waiting until he comes back. So we've gone through the overview. Now we are going into the specifics, right? Now we've picked list, and list is very, very important, right? In fact, all these are important, but in a very important way. List is important to know, and understanding lists and a number of things, a number of operations we are going to perform with lists would also make it easier in a way to understand the other ones. And just to reassure you, these are not complicated stuff. Remember the analogy? You already know the data types we have in Python that you can work with. Data structures are just like structures. Like, it's more of a collection, how you can carry a bundle of these things together, right? If, for example, let me know if I'm still. Let me check this. Right. Imagine that with what life would have been if we did not have something like data structure. This is what life would have been. I have a student whose name is Mark. And I want to store values for his performance in the exam. So that means Mark English. The only thing I have is variables. Mark English is equal to what? 79. Then I would have to create another variable called Mark Maths is equal to 98. I have another variable called Mark Geology is equal to 37. Mark Agric is equal to 67. Finally, I have Mark Economics is equal to 86. Now, mind you that there's no way Mark would have been the only student I have, unless it's a very strange school that only accepts one student, right? So that means if I have another student that has a different name, of course I have to compile their own this thing too. I will still need to create this kind of list of variables, right, for as many students as possible. But data structures has simplified this process for me such that I can have a dictionary that I would just, maybe it makes life easy for me such that I can just create a dictionary that contains records for Mark, right? And it's even possible to still have a dictionary of dictionaries so that I have record for Mark. Let's say I have record for Mark, or let's say scores is a dictionary, and then I have maybe I have dictionary that contains, let's say the one for Mark, right? The one for Mark. Let's see. The one for Mark, of course, it has to be this, right? The one for other students, and so on and so forth, so that I can easily index all this, and like I can have all of them in a more organized order, right? Instead of having to repeat a lot of things. Now, that is what data structure is all about. Sorry for my background. Sorry for my background. I guess it's noisy, but don't worry. So that is what data structure is all about. It's not like it's any complicated thing. If you are going to fetch water, you know that you are going with a jerry can or a plastic container. If you are going to the farm, you know you go with baskets, right, and so on and so forth. If you are going to fetch water and you go with basket cannot hold water. If you are going to the farm to maybe to carry your farm produce, you definitely will not go with plastic jerry can also, because it will not just make sense. So those are what data structures are. So let's look at list, for example. List is we already defined it here, that it is an ordered mutable collection of items. So there was no point coming to redefine it. So we'll just see how we can create a list in Python, and then it's very easy to do. Let's see two ways we can create a list. The first one, you can just start by creating an initial empty list, right? Just as you can see here. This command, in short, the only thing you need to create a list is just to have two square bracket. That's a square bracket, right? But because we want to give it a name, assign it to a variable, we now have to express it like this. Of course, you don't just have to come and start writing maybe something like this. It will not be very readable, and if you want to refer back to it next time, you cannot, because you did not give it a name. So hence we need to create the list by giving it a name, and then this character, opening and closing parentheses, instantiates the list, and Python already knows that this is a list, right? It will treat this as a list, but in this case this is an empty list. So if we print it out, it returns this for us. That means it has created, right? Now the note here says that the square bracket above is used to indicate a list, right? Now we can confirm that this is actually a list by using this type function to know the class it belongs to, and if I run it, you see that it returns for me that the class belongs to the class list, right? So this is a valid list, and remember it doesn't contain anything. So that's it. That's the first one. We can also, now remember that we just created an empty list that does not contain anything. So we can now start. Let's say I want to assign a value to that particular list. There are different ways, the methods that list offers us and part of it is being able to assign a value, to append a value to the list. And then this method called a method is a function, or a function you define on top of maybe another function or a class, like different ways you can different operations you can operate or you can perform on that particular class or so, right? So in this case now, I want to append the value of 10 to this list, so that my list becomes my list dot append, then the value I want to append to it becomes 10. So it now contains 10. So let me see if let's see. There is an error. Let me see something like this. Well, I think this is mostly what I can do. But let's just proceed. I've appended another value. I can append the third value. Okay, let's say 30. This is the first, second, because I ran this code twice in the third time. Okay, let me just go back a bit. Let me just recreate that list so that everything can make sense. I've recreated it by rerunning this cell that contains the line of code where I created it. So let me print it out again. The class still remains list. Now let me append the first value, then the second value, which is 20, then the third value, which is 30. So when I print the list, the updated list is now containing values 10, 20, and 30. Right? Now that's the first one. If you want to start appending, right? One way you can do this is, for example, you have created a code that asks maybe a number of users maybe you want to collect a list of all the students that took a particular course, right? You don't have that particular list immediately. You want the students. You have built an app that requires each student to enter their own value, their own registration number. So you can just do this by creating a place whereby each time a student enters their record, right, you append that particular value to the list. That increments the list and the list continues growing. Or let's say you have built a weather station that takes readings of something like the radiation. What are those things they do in this thing again? Let's say rainfall, right? And every morning it is supposed to perform the operation and then add the value of the average rainfall that's every day to that particular list. And that means for a particular year you're supposed to have about a list that contains up to 365 data points, right? You can use list method to continue to update it, right, automatically. That means it will be logging the file. It will be logging. That's day 1, it will come and log this. Day 2 is come and log this. Day 3 is will come and log this, and the list continues to build up until the end of the year. So that's it about appending, using append to add value to the list that you already created. Another way you can do it is you can also create lists by placing the values within a square bracket. That is, the value in the list need to be separated by commas. What this is saying is that if you don't want to, maybe you already have the list you want to create, you already have the values at hand that from the time you are creating it, right? From the time you are creating the list, right? You could just specify it immediately. Like in this case now, I want to create a list of even numbers from 1 to 10. I mean from 1 to 10, right? So which are 2, 4, 6, 8, 10. I have these numbers already, right? So I just created them as a list. And if I print it, it returns this for me. So what is now the difference between the first one and the second one? It's still basically the same thing, because it's still the same square brackets that I called. Forget the fact that this is the variable name, which I said is not really required but necessary, right? So it's still the same as coming to, maybe I copy this out. For example, I copy this and I come to another cell here below and I paste this. If I run this cell, it's going to return for me. if I call a method something like type, it returns list for me because it's still a list, right? But I have this value at hand, so I just created it initially, and then that does not also prevent me from appending to this list later in the future, right? We still have a section dedicated to different methods you can call on a list, but let's just demonstrate this one. Let's use this one for a demonstration purpose. So let me just see if I can append a value. The next even number after 10 is 12. So let me call this method even nums dot append 12. Now let me call that list called even nums print. You can now see that the list now has 12 appended to it. So what append does is that it takes whatever value you want it to append to the list and adds it to the back of the last value in the list. Initially the list was 2 to 10, right? Then it now added this comma to separate it, then appended the value 12 after the last number, which was 10. Now we can print our class. Okay, yeah, this is to show that this is a list. That's to print the class. Now a few things we can do about lists is that we can just know that Python lists can hold values of different data types. This is very important. If it were something like a vector in R, right? We already know that vectors can hold only a particular data type. If it's going to be a number, if it's going to be numbers, it has to be that numbers. If it's going to be characters, it should just be that characters. But lists in Python is different, being that it can hold. If you can still hear me. Can you still hear me? Hello? Hello? Hello?
Battery has died though.
Can you hear me? Can you hear me?
That battery was
Hello?
that battery was looking very. Kenneth, are you back?
Yes. Can you hear me?
I was thinking your battery died. Yes, we can hear you.
Okay, so my battery is still at 23%, so it can still take us for some minutes. Might. I think I have a number of things like this class is streaming live on YouTube, as you can see here, so it's also contributing to my battery
Oh wow.
dying fast and all that. So
it
I don't know how long
battery.
I was
All right,
off.
let's try and see.
I don't know for how long I was off. Hello?
Just, I think within 1 minute. I don't think you are off for a very long.
Okay, maybe can you tell me exactly what I said last, if you can remember?
No, you were explaining this what do you call it, Python list.
That
The lists.
Did you hear when I said that list can hold
I
values of different types? Oh God, my network is trying to frustrate me. Hello? Hello? Hello?
Nigeria,
Hello?
battle network, battle electricity.
Hello?
Yes, we can hear you now.
Okay, sincere apologies. Airtel is just. I think the main challenge I have now is even this my network. My network that is just frustrated. Can you see my screen? Can you still see my screen?
Yes.
Okay. Thank you very much. So back to what I was explaining. Lists, for example, can hold values of different data types, right? And then what that means for us is that it's unlike other kinds of data structures in other programming languages like R. Like we know that R a vector in R can only hold a particular group of values. That means if if it's supposed to hold numerical values, it has to be numerical, not numerical and then characters. Now you can see that in this case, I have this list called mixed stuff, which is a list holding both characters, numbers. Like here alone, you can see different types of data types as we covered in the other day. These are strings. This one, this one, this one. This is floating point number. This is an integer. This is a boolean, right? Can you still hear me?
Yes, you can hear you.
Alright, thank you. So that's one thing to know about lists. It can hold different. So if I print it out, it prints this for me. So if you have values stored in variables, you can add those values to a list using the variable name. Well, that is just to say, and I think okay, let's say I have this A equals 2, B equals 3, C equals 4. Right? I can add this to a list. Maybe I create a list of characters, or let me just call it characters equal to a list containing A, comma B, comma C. Alright, so if I print this out now, maybe I have characters. If I call this, it returns for me those values I stored in the list, which are 2, 3, and 4. Right? It did not return for me A, B, and C. It returned for me the actual values that were stored in that thing. Right? So that's what this line is trying to say. Now it's just like telling us different ways you can create a list, right? Now the other one is that a list can also contain other lists, that is list of lists, and this process is called subsetting. To subset a list means to create a master list that contains other lists. Okay, now let's say the number from 1 to 10, you can group them into odd numbers and even numbers, right? So I have a separate list that contains odd numbers 1, 3, 5, 7, and 9. Another list that contains even numbers 2, 4, 6, 8, and 10. So that means if I combine these two, right, it can give me the full list of numbers from 1 to 10. So now this list, the list of lists or master list, which I call all nums, can comprise of odd numbers and even numbers. Now let's print it out. Upon printing it out, you are going to notice something different. In this case, you can see that we have this parenthesis, this square bracket containing the first value, another square bracket containing the second value, then a bracket that contains everything, right? Meaning that this one is, it still preserves the fact that this one is a list on its own, which is this one, right? Then this one is also another list on its own, which is this one. So what this is telling us is that lists is just like a structure that contains whatever structure you want to place inside of it, right? So it did not, it's a different thing having them as separate lists from a case whereby the two numbers, the values in each of these lists were combined together. I hope I'm making some sense in this case. Like, are you observing this with me? That I created a list that contains other lists, right? Is it clear to you now?
Yeah.
All right, thank you. So in this above example, we have the two lists, odd numbers and even numbers. We added to a master list called all nums, right? Having known this, what next can we do? There are still other ways you can convert. You can create a list. For example, converting from a dictionary to a list, right? I think we have another section that covers that, but I'm not sure we're going to cover up to that today. So now let's look at different things other things we can do to a list. We have a list that contains, which is like a structure that contains a basket that contains our value for us, and then the purpose of storing those values in a basket is so that we'll be able to access them later, right? So that we'll be able to access them whenever we need them, right? Now, the thing about lists is that you can retrieve an element stored in a list using method called indexing, right? If it is just one element, from that list that you want to retrieve, you can use indexing to do that. Now, this is how indexing works. When you store values in a Python list, each value is assigned an index number that corresponds to its position in the list. That is why part of why I say that lists are ordered, right? So that you can always trace the value in a particular position, right? Like you can see here now, right? In this list, for example, let's say in this list, for example, this number 1 here, right, is given a value that corresponds to, okay, I can create an index. Let me say index list. Index of this odd number is going to be something like 0, 1, 2, 3, and 4, right? That means it's like we are mapping these two things together, so that this value 2, this value 1, the position is at position 0, right? This value 3 is at position 1. This value 5 is at position 2. 7 is at position 3. 9 is at position 9. Position 4 rather. So at any point, if I want to know the value at a particular position, I can just reference the index value, right? And then that retrieves for me the value that it's holding. We are going to see an example of that shortly, but the next few lines is just to add more explanations towards maybe how indexing works. So this is how indexing works. When you store a value in a Python list, each value is assigned an index number that corresponds to its position in the list, right? Now, there are two ways you can assess that. Is either you are moving from left to right, which is usually the most popular method, at least for those of us in this part of the world that we read from left to right. It's very common to us. Or you can choose to move from right to left, meaning that you are moving from, that is the normal sense of moving from here to here. And one of the things that can influence your choice of where to move from is the position of the value you are looking for. Let's say this is a list that contains up to 1,000 values, right? And the last value you are looking for, and the value you are looking for is just the last value in the list, right? Instead of you to start counting from the left to know the index number of that value, right? Then you can start from the right instead and move towards left. It is easier for you, right, to memorize. Now, there are two things that can happen. There are a number of things can come into play depending on whichever path you choose to follow. If you are moving from left to right, the first element in that list has an index of 0, and then that means the second element has an index of 1, and so on and so forth, right? But if you are moving from right to left, the last element has an index of -1. Then the second to last element has an index of -2. So that means if I go back to this list now, and I'm moving from left to right, this is at index 0, at index 1, 2, 3, 4. But if I'm moving from right to left, this last element here has become the first element, right? Then it has the value of -1. So this is going to be index -1, index -2, index -3, index -4, and then finally index -5, right? That is moving from right to left. That's how you know the index value of the particular number you're looking for, right? So now, with this index value, you can actually pick out the particular element you're looking for, right? I think I'm off again. Oh God. It's okay. Sorry. Sorry, yeah? Yeah, don't cry. Yeah? Okay, yeah?